Okay, so today we're going to continue Chapter 3, focusing on logarithmic functions. If you think back to yesterday, when we talked about your exponential functions, if you remember, your basic exponential function crosses through that point 0, 1, and looks something like that. So, since this passes the horizontal line test, remember the horizontal line test, it must have an inverse function. Okay? So the exponential has an inverse function called a logarithmic function. Now, if you remember about inverse functions, so the first thing that we remembered with inverse functions is that when you had your x and y values, you just flopped them. Okay? Alright. One other thing I want to do, and we're going to add this to our rules for Chapter 3, but I want to be able to talk about something in log form and something in exponential form. And you're going to need to be able to go back and forth between the two forms. Okay, so in log form, it's y is equal to log of some base b, x. Okay, this becomes the exponent, and this is your base. Now, most of us prefer to be in exponential form. It's just what we're familiar with. Okay, so your exponential form would look like the base raised to some exponent is equal to x. Okay, so this is your base, and this would be your exponent. Alright, so let's practice going back and forth to start our lesson. Alright, example 1. Write each equation in exponential form. And I'm just going to abbreviate if that's okay with you. Alright, number 1. Let's say I have 3 is equal to log of base 7, x. And I'm going to actually go ahead and have you copy the 3 problems down, and then we'll talk about how to do them. Sorry about that bell. It's lunchtime when I decided to record this one. Alright, so the easiest thing to do, remember that this is your base, this is your exponent. So I like to do something called loop-de-loop. So I start always with the base, so 7 raised to the 3rd power is equal to x. So number 2, begin with your base. So this log is base b, loop-de-loop. B to the 2nd power is equal to 25. Alright, you try the last one. I've written it backwards, but you're still going to loop-de-loop. You're just looping this way. And I apologize, I want to look into this microphone sometime this week. It feels like I'm getting a little bit of a feedback from it, so I'm not sure if it's just too close to the computer. Let me see if I move it further away. Pardon the cord. Let's see if that gets rid of the squealing sound. Alright, so after all that chaos and me moving everything around, were you able to get 4 to the y power is equal to 26? Okay, I do real well going from logs to exponents. Not so much the other way. It's really the reverse process. Example 2. Write each equation in log form. Okay, again, let's copy them down first, and then from there we can go ahead and add to it. Alright, so 2 to the 5th power is equal to x. B to the 3rd power is equal to 8. And e to the y power is equal to 33. So if you look back here, this number, right, the 7 becomes my base. So this is log 2 of x equals 5. Okay, so it's backwards from here. Your exponent goes alone, so the exponent goes alone, equals, that's my base. Okay, so let's try number 2. Exponent goes alone. This b is my base. Now, if you ever want to check your work, if you're just like, man, I'm not real sure, do the loop-de-loop, because most of us can loop-de-loop and make sure that it matches. Alright, so number 3, you try exponent alone, log of the base. So hopefully you got y, the exponent, is equal to the log of e, 33. Alright? Now, let's talk about how to evaluate some of these without using a calculator. Alright, example 3. Evaluate without using a calculator. Okay, and before you have a heart attack, just relax. It's not as bad as what you think. Oh my goodness. Make that a... There you go. That mighty big O for log. Go back to number 1 and add a little 10. We're going to talk about that in a minute. So, first thing we're going to do is write them in exponential form. So, first thing I want you to do is loop-de-loop. I originally left that 10 out because what we're going to find out in a minute, and I just haven't given you the rule, is that if I don't give you a log, it's understood to be base 10. Sorry. So 10 to the x power is equal to 100. Now, how could you write 100 with a base of 10? Do you agree that 100 is 10 squared? Now, at this point, because the bases are the same, you drop them. So you just drop the bases and get x equals 2, and that's my answer. So we have no reason to get upset that we don't have a calculator. Okay, so I'm going to help you set up number 2, and then I'm going to let you try it on your own. Alright, so first go ahead and loop-de-loop. So 3 to the x power is equal to 3. Alright, so these already have the same bases. So I'm ready just to drop the bases, and x would equal, what's the exponent of this 3? Remember there's that imaginary 1 up there, so x would equal 1. Now this one's going to be a little trickier. So first, go ahead and loop-de-loop. So do you get 36 to the y power is equal to 6? Okay, now, I'm going to have to somehow get this to a 6, right? Because this is going to mean I don't want to make this a base of 36. So my question is, what do you have to do to 36? What power do you raise it to? Well, I know what you guys are thinking is, Ms. Hoffman, you wouldn't raise it to a power, you just take square root. When you take the square root of something, if I take the square root of x, that's really raising x to the 1/2 power if you go back to what you learned with square roots. So really this is 6 to the 1/2 power. So y would equal 1/2. Alright, some important properties of logs. First one, if there is no base, it's understood to be base 10. So if no base is given, it is known to be base 10. Alright, a couple more things. If I have log of base b of b, I get 1. The log base b of 1 is 0. And these will all make sense. I'll show you how they're going to work. Log b of b to the x power is x. And b raised to the log bx is also x. Okay, again, looks worse than it really is. So let me show you how it's really going to look so that we don't have any problems. Alright, so example 4, evaluate. Let's say I have the log of base 7, 7 to the 8th power. And I have 3 log 3 of 17. Okay, so here, notice that the base and this are the same, so essentially, by our rules, they just cross out, and my answer is 8. And likewise here, 3 raised to the log of base 3, they just, for all purposes for your concern right now, they cross out and you're left with 17. Alright, so far so good. Alright, let's graph one and see what the logarithmic function looks like. Alright, and I'm going to grab a new sheet of, oops, sorry, hit the microphone. I'm going to grab a new sheet of paper. Example 5. Lots of examples in this section. First, I want you to graph f of x equals 3 to the x power. So I want to go back and regraph that function we graphed yesterday. And then I want you to graph g of x, which is the log 3 of x. Alright, so let's start off by just graphing f of x. So x and f of x. Let's say I just go with -2, -1, 0, 1, and 2 again. Alright, so f of x is 3 to the x. So I'm going to come over here and do 1, 2, 3, 4, 5, 6, 7, whoops, 8, 9. Okay, so 3 to the -2 power is 1/9. So at -2, I'm at a 9th. 3 to the -1 power, I'm at 1/3. So at -1, I'm at a 1/3. At 0, 3 to the 0 is 1. At 1, I'm at 3. And at 2, I'm at 9. Now let's graph function g, which is really the inverse of my function f. which is a good thing, because to have to take logs, it would be a little tedious. But watch what we can do. Since these are inverse functions, what do you remember we can do with the x value and the y value? Do you remember from chapter 1 that we can flip those? So I get x is 1/9, negative 2. So when x is 1/9, I'm at negative 2. When x is 1/3, I'm at negative 1. When x is 1, I'm at 0. Oops, put it in the wrong spot. There it is. When I'm at x is 3, the function is 1. And when I'm at 9, the function is 2. So that's what a logarithmic curve would look like. Okay? I'm going to write you a note if you missed that. You switch x and y since they are inverse functions. Except you can't see what I just wrote. There you go. So, let's talk a little bit about the logarithmic function. What would be the domain of the logarithmic function? So the domain is where on the x-axis does this function exist. So do you agree it's 0 becomes a vertical asymptote, so it's going from 0 to infinity, and his range is along the y-axis, and he's going from negative infinity to infinity. Okay? Alright, last thing I'm going to leave you with. I would like you to pull your shifting rules back out that we started yesterday. And I want to go ahead and add to them. So, in the middle, I'm going to put, I think I'll use purple, I'm going to put our logarithmic functions. So a vertical shift up or down is going to look like log b x plus 1. And a vertical shift down would be log b minus 1. So again, that plus and that minus are not attached to the actual function. Let's talk about a left and a right shift. So it's still log to some base, but this time to show you I want you to go left, I'm going to put it in the parentheses. So it's part of the actual function. And if I wanted you to go to the right, we're going to make it minus 1. Because remember, when it's contained in the function, it's opposite what you think. Alright, here g of x is equal to the negative log of some b. And to flip it over the y-axis, I'm going to want that negative contained in the function. And then finally, to do your stretching and your shrinking, it would be 2 times the log b of x. That would make us multiply the y-coordinate by 2. And then if I wanted you to divide it, I'm going to take that 2 and put it into the function. Okay? Alright, we will practice this tomorrow in class. I do want to just talk to you about one last thing, which is the inverse of the natural base e. Okay, so back in your regular notes, and this is where we'll leave off, the inverse function of the natural base e the inverse function of the natural base e is the natural log function. And on your calculator, and even in the way that we'll do the natural log is ln. I don't know why it's not NL, but anyway, it's log natural, I guess. So that's where we'll leave off today. Don't forget to try your practice problems, and I'll see you tomorrow at the beginning of class. Have a great evening.